Hello and welcome. In today's video we are dealing with moles, and by moles we mean moles in chemistry and not moles you might find in biology. Can be quite a tricky topic if you're not quite clear, but we're going to try and clarify it for you so that you are a bit more confident with dealing with moles. Now, on the very first and very basic level, moles, or a mole of something, is actually just an amount. Okay, it's just an amount of something. Now, if I tell you what that amount is, it's this number here, 6.02 times 10 to the 23. And if I was to write out the whole number, it would look something like that. That is 602 something, whatever that number is there. But it's quite a large amount, and a mole of anything is that number of that thing. Now, we could actually apply it to any item. You could even say I've got a mole of, I don't know, oranges or something like that, and that would mean you would have this many oranges. But we don't generally deal with any item other than atoms when we're talking about moles, and the reason for that is that masses on individual atoms are very, very tiny, so we have to deal with large numbers of them together in order for us to be able to make any sense of any calculations that we do, or to make them much simpler to do and to look at. There is another reason why this particular number was chosen, and we'll look at that in a minute. But for the moment, all you need to remember is that a mole of anything is this number, this amount. It's just like saying a couple of things, a couple of bottles, that would be 2 bottles, or a dozen cakes, that would be 12 cakes. It's just an amount, and it's a name for an amount. Okay, so second thing I want you to remember, and this is to do with the reason why that number has been chosen. It was chosen carefully so that when you have a mole of an element, it has a mass which is the same as a relative atomic mass in grams. Okay, so 1 mole of an element has all this, right? What does that mean in practice? Well, let's have a look. If I've got carbon, 1 mole of carbon has a mass of, and we can work this out using this idea here. 1 mole of carbon has a mass which should be the same as the relative atomic mass, and if we look at carbon here, the relative atomic mass is this top number here. Okay, so that's the relative atomic mass, sometimes written as AR. And if you're not quite sure by this idea of relative atomic mass, I've done a video on it previously which you can look at just to clarify that. But for now, relative atomic mass is this number here, and a 1 mole of carbon has a mass which is basically that. So all you have to do is just take that, put it over there, and there's your answer. 1 mole of carbon has a mass of 12, and we have to put in the units, which is grams. Okay, and similarly with oxygen, 1 mole of oxygen has a mass of, again, we just look at the relative atomic mass there, bring that over, and there we have 1 mole of oxygen with a mass of 16 grams. Okay, so that's a very simple case. Now, something else I want you to remember is this idea here, 1 mole of a compound. So now we're dealing with a compound. Before we were dealing with an element, now it's a compound. 1 mole of a compound has a mass which is the same as the relative formula mass in grams. Now, if you're not too sure about relative formula mass, I will go through it quickly now, but if you're not too sure and you want more about this, there is also a previous video about that which you can look at, and that will explain it for you. Now, for now, if we move on, 1 mole of a compound has a mass which is the same as a relative formula mass, so let's have a look at how that looks. We've got magnesium chloride here, which has a formula of MgCl2, and the first thing we need to do is to work out the relative formula mass, and that can be done by adding up all the relative atomic masses. So here I have the relative atomic masses there, and to add them up, all you do is 24 add 35.5, but remember MgCl2 here, so there's 2 chlorines, so it's plus 35.5 again, and the answer is 94. So 1 mole of magnesium chloride has a mass of 94, and don't forget the unit, which is grams. Okay, so these 2 bits in pink are quite important for you to remember, and you'll be using these either as it is on the screen here in an exam question maybe, but also you will need to use this idea for some more advanced calculations that we'll be doing in a later video. Now, just to wrap it up, here's a couple of questions that you can try it for yourself. So you can pause the video here, try out these 4 questions, see if you can get the answers right, and then you can just check how you've done, and if not, maybe you might need to go and look again. But if you pause now, and then I'll go through the answers in a sec. Okay, so we've got sodium here. We want to know what one mole, the mass of 1 mole of sodium, and remember we just look at the relative atomic mass there, so it's just a simple case of moving that over. It's 23 grams. For H2O, well, this is a compound, so we need to know the relative formula mass, and to know the relative formula mass we need the relative atomic masses. So we've got H equals 1, O equals 16. Remember, we've got two H's there. It's H2O. So we'll have 1 plus 1 plus 16, and therefore that would be 18 grams. For carbon 12 over here, well, I'm asking for 2 moles this time. So if 1 mole has a mass of 12, 2 moles must be double that. So it's 12 times 2 equals 24. Don't forget the units. And for water, well, this time we want 3 moles. The mass of 3 moles of water. Well, we need the relative atomic masses and the relative formula mass, but I've done that up here, so we can use that. Relative formula mass is 18, but we don't want 1, we want 3. So that would just be 18 times 3, which is 18, 36, 46, 56, 54 grams. Okay, so there we have it. 2 key things that you need to know about is this idea of a mole being an amount of something, and the second key idea is that a mole of an element is this and a mole of a compound is this. Okay, so thanks for watching. Hope to see you again soon.